Hello, everybody. This is Steve. I'd like to welcome you to my YouTube channel for the Commodore 64 game project, and this is for video 4. And what we're going to be learning, taking off from the last series, is now that we have gravity actually added to the project, we're going to be able to move up and down poles that are actually created inside of the maze of the levels that I've created. So the last project we had gravity, but I didn't actually include a second video since I could implement and show you the gravity, which is pretty straightforward, which I'll show you in this video also, which is falling off until you get to the bottom. But there would be no way to climb back to the top, so I figured that video would be pointless. But this one, you're going to be, like I said, you'll be able to actually move up and down ladders and stuff. When he gets to the top, the screen will scroll up. And then when you get to the very bottom of the screen, dropping off and going down the ladders, however way you choose to get there, you're going to see a river down there that you can actually float in. And he can also exit the river by finding a ladder and moving back up and down it. So let's get that started. It's going to be interesting. Okay, everybody, we now begin the Commodore 64 game project for video 7. As I mentioned, in this video session, we're going to be learning how the player can interact with ladders in the game, which are known as material objects according to Chartpad. And from there, they will be able to move up and down. As you see on the screen here, an example of a sprite sitting on a ladder and there's overlooking a river. And also, even though I stepped it up a little bit here, we have river additions added to this, even though it may not be included in this actual project. But later we'll have animation and stuff like that of the river and the player moving. But for now, I just wanted to add that just to make it more variety here. So let's get this started. And as always, I appreciate you guys can subscribe to my YouTube channel, really help me out grow. And you also see there's a Facebook page here, which I often try to keep, up to date on. And I can answer your questions too. But you also feel free to leave comments in the YouTube channel as well. But any questions, things you're stuck on, projects you may be working on. And here's the code samples. I always keep them on Github, as mentioned before. So anytime you need to see the latest download for video 7 in this case, it will be available here shortly after the video is uploaded. Okay, so what will be learned in video 7? So for this session, the sprite will now have the ability to move up and down the poles when in contact with them. If the sprite walks off a pole, he will fall either to the left or right, depending on the direction he is facing. When the sprite ascends to the top of the ladder also, the screen will scroll up to align with the sprite at that position. Finally, when the sprite makes contact with water, he will float. The sprite can be moved in any direction in the water. It can also reach up to grab a pole to exit the water. And you also discover that he bobs up to the surface. And here's the file we're speaking of, player routines.asm, that we will be discussing in this video. So the first thing, even though we talked about this in the last video, I've actually gone ahead and made several changes to the applied gravity here. In the last video, I think I was just showing you like how to use the gravity and then get the player walking off and on ladders here. And I've kind of got that general concept now, except I've kind of implemented a little bit better, and I'll be able to explain a little bit better here for you now. So if you see this first variable here where it says sprite char POSY, this is keeping track of the sprite's position at the character screen position. Now keep in mind the screen goes from 0 to 40 across, or 0 to 39 across, and I think it's like 0 to 22 or 24 down. And each of these individual sections, like where you would be typing in letters when you're writing a basic program or whatever, is going to be made up of pixels in an area of 8 by 8. And this position for the sprite is trying to position at that exact position, but the sprite holds its own different pixel positions, so we have to kind of align those to get those to go together. So I've explained that in earlier parts of the project, but I wanted you to understand that's what's going on here. And what this is doing here is it's checking what's called the player down cap. So as the sprite is falling down the screen, which is what this routine is doing, it's checking to see how far down the screen has he gone. So if he's going from top to bottom, once he reaches the bottom, that will be the player down cap position. I put +1 so that it looks like he's actually falling off the screen here. And the BCC means if he's less than that, it'll actually go to the sprite falling position, which will just have the sprite moving down the screen. I'll jump down to that for a minute so I can kind of keep you in line here for a minute. So right here, we'll jump down to the sprite falling as if we're thinking like the computer for a minute. So the first part, after you've checked that sprite's position to its character position, he's just going to move the sprite down. And this, again, is representing our head sprite, and this is our body sprite. So the top and the bottom, the head and the legs. Now going back up here, now if he's not falling down the screen, we're going to be essentially checking the next position here, which is going to check the map position. Now the whole map itself is made up from map X position going horizontal and map Y position going vertical. So in this case, we're going to check to see how far the map has scrolled before we actually are able to manage the applied gravity area. Now these kind of work together. The map position is keeping track of the scrolling, because if the sprite's falling down the screen and you're not keeping track of the screen will actually scroll up. I tested it by removing these routines, and the screen will scroll right up, and the sprite will be way off the top and eventually off the screen. So it's important to kind of keep those in balance and keep them aligned to the screen, which is what this does. And down here, we got the map Y delta. So if you remember from, I think it was video 1 or 2 where I talked about deltas, I think it was probably video 1, where the sprite is moving through a pixel, or he's moving through a tile from 0 to 4. After he gets to 4, he's already passed through that delta. So this is just checking each time the sprite is falling down the screen, he's checking those deltas. And this is saying if it's less, so we're going to keep scrolling the screen. So if we're still inside that delta, we're still scrolling the screen. And if we're still inside the map position, we're still scrolling the screen, which is what this is doing right here in the next routine. It's just a simple routine. It says scroll down. And what it is basically it's a variable marker that is controlled by our update scrolling. I believe it's our update scrolling subroutine, which is managed by the scrolling.asm file, which I've explained in like video 3 or whatever it was when we were talking about the scrolling part. So essentially, sprite screen can be scrolled down, up, left, and right. This is just allowing the screen to scroll down, so we got to emulate the effect of the gravity, essentially. And right here, we're checking to see if the joystick is moving. Now, this is the new stuff I've added into it. Although we had some kind of implementation of this before, I found out this one works a little bit better. And it still needs some refinement. I won't kid you not, because sometimes I'm trying to walk and the screen will kind of do some strange tearing of the screen and stuff that I haven't fully corrected yet, which is why these videos have been delayed so long, because it's not perfect, but I felt that it's time enough to get a video out to at least show you where I'm at with that progress. Okay, so here's the right movement of the sprite. So as the sprite's moving, it's also going to be essentially scrolling the screen. So as the sprite's starting to fall, the screen is kind of supposed to go with him. But like I said, there are some bugs in it where it essentially allows him to move right after a period, but he gets stuck on the screen. And maybe I'll demonstrate that later. It's just stuff, if you guys know of any answers to fix this, it'd be great. Except it would require a full rewrite of the scrolling.asm file, because I did look it over, and everything is, after it hits this RTS here, it's going back to the last subroutine that called everything at that point. I believe that would be called off the stack or whatever. And at that point, it would actually be reading the next subroutine in line, which is the scrolling, but it's also still remembering the right fall movement, and also the joystick movement is being tracked. So sometimes it'll end up stopping the position by the time the sprite gets to the bottom of the screen. But anyways, this is the right and this is the left movement. And we went over that one earlier. Okay, now for the next subroutine, you notice we've been working on the player state idle. Keep in mind, the player state idle is the heart of the entire program. This one drives everything. So from your sprite movement to your sprite's collisions, your gravity would be added, everything would be added here. So think of the player state idle. If I hold up my joystick here, as my joystick's just sitting here and I'm not doing anything with it, it's in an idle position right now because I'm not moving to the left, I'm not moving to the right, up or down. So as it's idle, it's going to start checking all these things, which is where you can implement gravity. And also you can say, okay, maybe when he's sitting idle, he might be going to the left, maybe he's going to the right, maybe he's going up, and maybe he's going down. And everything is controlled right from here. Now, you probably notice in these series, I'll have to admit it's maybe not 100% or maybe even 75% comprehensible and able to follow, because what I'm doing is I'm breaking down each subroutine. I'm showing you the newer changes I've implemented. Otherwise, I have to go through a whole lot of code each time. Every time I update an entire project, I have to say, okay, Here's the entire code. Here's what I changed in it. And I felt like that could be a little bit more complex. Maybe later I'll put the whole program out there so you can see the entire thing, which you'll always see in the main videos, by the way, and then kind of break it down there and say, these are the changes I made for this or whatever. But essentially what's going to happen is by the time we get to the 14 videos, at that point, I'm going to essentially try to continue the project as much as I can. Now, I have other time commitments in my life right now, which careers and such not. And I also, have a marriage that I'm maintaining right now. So, because I'm busy with so many things, I may not always be able to get a video up out like I'd like to every single time, but I want to try to, give you something each time. So, what I was planning to do by the time we get to that stage, which should actually have a lot going by that time, fingers crossed, right? So here's the hope that by that time we have the music going, collisions, we have enemy sprites moving around on the screen. Maybe start adding some different things to kind of make it more variety and maybe try to start building some type of realistic game out of it at that point. But it'll just be like new changes that I update and say, hey, here's something I created with a sprite that's shooting at you or something like that. And maybe the next week I might be showing something. Here's some weapon pickup or something like that. Just kind of those things that go along. I mean, I'll be 100% admit I don't really have like a total plan to it. Originally, I wanted to create some kind of a parkour adventure where I love parkour. It's essentially just a player moving around, kind of like if you ever played the Mirror game where you're jumping from rooftop to rooftop. Except in this one, he would be running around, and it's kind of a funny story. I think I've told it once already where essentially this as you were going parkour with your friend one day, he got held up or kidnapped by a gang and you had to go find him and stuff like that, and you start learning all um, these skills to become really good and to defeat all these gang members along the way. You might run into security guards, things that you would actually run into in a parkour situation. If you ever watch YouTube parkour videos, are really cool because people will emulate real life situations like they're running from security guards, although you'll never see them up against gang members. That's just for the game aspect. So hopefully that explains that better. So breaking this down, going into this now. So you always got the player substate, which is the first entry to always load up the actual animation for that state. And the player state idle is just a simple animation where you've seen it like in the actual video when I'm not touching the joystick and his feet are kind of moving up and down. That's the idle position. And that's actually implemented from the Indiana Jones Temple of Doom sprite. So that's what we're doing here is we're loading in the sprite animation idle. And then once we're done with the idle, we exit back out. So basically this keeps the idle going and this keeps the project running. Now, this one, I've done a little bit of breaking down a little bit more, and I understand joystick ready better than I probably did before. I noticed the joystick ready actually isn't really even checking a joystick. So maybe it's not the best routine. Remember, this was a project that was handed down to me many years ago from the machine language project. The joystick ready is actually controlling whether the screen is going to move or not. And here I put once it's equal to 0, the screen has stopped scrolling. Otherwise, again, if we hit that RTS, we leave this subroutine and go back to where the last JSR was called, which is to jump to subroutine, which is essentially back at the very beginning of the main routine and the main.asm file. If you look at the original projects or look over the code, you'll see what I'm talking about. And inside of there, the next subroutine or somewhere around there should be the update scroll, which manages that scrolling.asm file, which controls, of course, whether the screen is moved or not. Okay, so moving on here. So now the next thing we're doing here, which you may have seen this already, but I'd like to break it down a little bit more, is we're checking to see if a sprite is climbing a pole or sitting idle on it. So this would be actually new, although you've seen me test for collisions of walls. Now we're going to be testing for a pole. So essentially, as soon as the sprite's moving across the screen, inside of a chart pad, you're creating materials that are being tracked by actual binary data that's being masked inside the program. So as he starts traveling across, it's able to figure out whether he's touching a pole, is he landed on the floor, is he in the water, or what is he? What kind of tile is he colliding with? So if we equal a pole, then we're going to just go to a routine called jump the pole climb, which I'll show you later is going to implement the movement up and down on the ladder. Now, the next thing to say, if he hasn't touched the pole, remember this is that idle position and we're just sitting here with our joystick. is saying, has he landed on the floor? Because we need to test for both because we're checking as the idle is just sitting there or falling. So if he's falling, he might land on the floor or he might land on a pole, which is why I have this put in here. So if he's landed on the pole, then we would go to, in this case, what I did is, even though I'm checking for the pole, I'm saying if the branch is not equal, he's still falling. So essentially, we're not checking for a pole yet, so we can kind of jump over this routine. So the still falling is going to implement the gravity because we want to show gravity if he's not on the floor yet. So the next step here is, okay, now that we know that the player has landed on the floor, I put check if sprite is a little below the floor. Now this is something I had to test because the sprites I'm using are two sprites. They're layered on top of each other. The Indiana Jones does this. So it's, again, we've got the head sprite, that's the 0 position here. That calls off and reads off the first base sprite, and then we got the next sprite underneath that. So we're checking again that character position to its sprite position on the character sprite position to its character position on the screen, and we're checking to see where is that colliding at. So essentially, I've done some math checking here, and I found out 14 is actually a little bit above the floor, enough to be able to reach and collide with other things. Because initially, if I didn't add this in, he would be sitting down on the second sprite, and it looks like he's kind of standing in the floor a little bit. And I know it still needs some work. It looks like he's still standing on there. Maybe I'll create like a little ground later or something, but just the things I'm learning about it. So if the sprite has landed on the floor, what I've implemented here is the ability to move him up a little bit. And this is just a bug fix that I found, and I haven't found an immediate solution, but for the time period I spent on this and the time that I actually have, I found this was the only thing I could do is move the sprite up a little bit if he's at that position there. So this is saying if he's less, move the sprite up. Otherwise, we're going to jump over this to the next horizontal check, which will be a past the gravity. Because you remember earlier, we were jumping past the gravity. If the sprite, for example, is not touching a pole and he's not touching the floor. So we're skipping over all this. And that's what you want to do in your project. You want to kind of move it around and say, okay, am I at this point in the position? If the sprite is not, if there's not a collision going on, maybe I need to be over here somewhere. Okay, so now we're checking after we've confirmed that the sprite is, we've already checked the positions for the floor. We've already passed the gravity movement. Now we want to actually check the actual joystick movement to see what's actually going on with the joystick. Is it being moved left or is it being moved right? And if it's not doing anything, we jump over to vertical check, which means we're going to check the joy Y, which is the vertical position of the joystick, or up and down. So in this case, if the sprite is of less than, so it basically a branch minus means if it's less than the value of the joystick X there, then it's going to be a negative value. So it's going to immediately go over to the left routine, which is what I got here. Otherwise, it's going to be a positive, which is a branch plus, and it means it's going to basically essentially move the sprite to the right. So it's kind of like this backward negative and positive that controls the joystick position for horizontal. And on the left position, we have the routine here, which you've seen this in the last videos, although I'm not going to talk about it in this video because we have a lot more to go over, and we've already kind of touched the walking left and right movement. Essentially, it just allows the sprite to move to the left, and it checks whether he's bumping into something. Okay, so the next one we got here, and this is going, this one is actually sitting here, I know, in the middle, but we'll come back to it. It's going to be for the water position, or water checking. Okay, so we know that if we were checking the horizontal position of the joystick, if he's not left or he's not right, then we're going to go to the vertical check, as we saw earlier. If you need me to go back, you'll see right here the vertical check right here. And then now what we're going to do, we're going to be checking whether or not the sprite is in the water. I always want to check this first because if he's falling, we need to see immediately what that Y variable is doing and track it before, because if I tried to add the joystick first, it would actually kind of suspend him in the air and stuff like that. So I found out this was the best position. Again, that's the thing you'll learn about assembly language in general, is sometimes you have to put subroutines before other subroutines and before other variables in code in order to get things to work right. So essentially we're checking the water, right? And this is, again, those materials from the chart pad project. And you saw earlier the go floating. I'll back up here a minute so you can see it right here. So this is going to call our floating position, which allows him to bob up and down and move around in the water. Okay, now we're saying if we're not there, then essentially if there's no water in the way, it's okay to now check the vertical position of the joystick. And here again, we're checking if there's no vertical position, then it means we're going to exit the entire subroutine. Nothing else is going on. The joystick is not being touched horizontally or even vertically at this point. And essentially, when we're in the idle position, I don't really need the joystick to be checked up and down because we don't want to be able to walk up and down the screen since we're not going to be able to walk in the air. We're actually simulating a 2D environment type project. So the sprite's moving around on levels and he's looking for stuff like poles to walk up and down, which is why we have the pole routine added. And of course, here it is, the state pole position. So and I like how that came out, pole position, but essentially it's the pole that's going to allow him to walk up and down. These are just those main calls. And of course, we had the punch right and the punch left. This was from the earlier project. So if you move the sprite in that position, he can punch or whatever. And just left that in there for purposes. And essentially here, we're now going to go ahead and check the pole. So remember back here again, I'll jump back here again so we don't go too super fast here. So I'll go back to where this goal pole climb is so you can follow me here for a minute. Because in assembly language, you're just kind of jumping around until you're finding out where you're going here. So where we got our pole position right here. I keep saying pole position. Pole position is actually an old game originally created on the Atari computers. So here we're checking the pole position on the screen there, and we're going to go to go pole climb. And if we go down here, we'll see go pole climb right here. It's doing this is calling a state called player state pole. And this is essentially just calling, it's a high and low byte format that does an indirect jump to execute code at that position, which is going to find the subroutine found there. In this case, it would be player state pole, which is right here. So again, we're doing these tests here to see whether there's animation going on. And here's our animation for our pole climbing, which kind of wobbles him up and down as he moves up and down the pole. Very similar to the idle, it's just we're changing the sprite in that base position in memory so we can switch out a different sprite and cycle through those frames. Okay, so as always, again, we're going to check our joystick to make sure our screen isn't wobbling up and down, which is what this mentioned the scroll would do if we didn't. And if our joystick is ready, that means it's not, the screen is has stopped scrolling, I believe that was. And at this point, if it has, then we're going to be able to check our subroutine. And the first thing we're doing here is notice again, as we're climbing up and down a pole, we're going to check the pole again because now we're in a totally different subroutine. We're not looking at idle anymore, player state idle. We're looking at the player state pole. So we need to actually check, since we've jumped out of that subroutine into another, what's going on with the sprite at this position as you're moving the joystick up and down. And as always, the very beginning, we're going to check to see if there's a pole there. And if there's not a pole, we're going to exit. So again, this is a call to drop it down to read the next position. So the next line down below will mean that we found that pole. Otherwise, we're exiting out of this pole subroutine. So here, as soon as we know that there's a pole found, we're going to be again checking our X, which is our horizontal movement to the left and right. And you'll see here we've got the left and right and the vertical check if there's no movement of the joystick X position. And just to kind of explain this, which you'll see here later, the left and right is necessary because you can move around on a pole. Essentially, if this wasn't done because the deltas are tracking the tile on that pole, he would actually fall right off the pole. So I learned later that you had to check those deltas to make sure he doesn't fall right off the pole. Okay, so essentially here, this is where we exit the pole. So we're not to the vertical check yet. We went back to, just to kind of jump back here a minute. Remember, we were saying back here, let me find myself here, no pole found, right here. If there's no pole found, so it's saying, is there a pole? No, there's not. Then we're just going to go down here to the exit pole climb and see what is the next thing we're going to do here. Now, this was actually originally left in here twice, but this shouldn't be in here, and I took it out of my original project, so just kind of excuse that for now, because I was moving code around to try to get it to do more specific detection on the pole. And essentially what it's doing here is we'll just say that this part doesn't, it goes to the exit pole climb, but we don't need this because we've already checked that earlier. we're going to be able to move up. So now that we're on the pole, we can move the player up because we've already checked to see that the player has moved the joystick up, so it's able to move the position up and down on the joystick here. If you see right here, it says left and it says right and vertical check. And it's just going right through the pole to check what the sprite is actually doing on the pole there. And actually, if I remember correctly, what this is doing is actually moving the player up the pole. I think I did this because, again, of that detection. If he didn't move up or something, like he would end up getting stuck or he wouldn't be able to leave the pole at that point. Like if he's trying to climb up a pole to get to the level above him. Okay, so now here's the right position. So we're checking to see if we can move right. Essentially, if there's a 1 found in this area, or 0, I mean, it's not blocked. If a 1 is detected, that means a collision occurred, so we would exit at that point. So if you're trying to move to the right and you're on a pole and there's something blocking you, like a wall there, you're not going to be able to go through that wall. Essentially, you have to check for that. Otherwise, the sprite's going to be able to pass through that area because we're getting in a different subroutine altogether. Okay, and then here's the walk state right routine. So essentially, it's just allowing the player to walk to the right as you push the joystick to the right. And here's our left, the same thing. With our left, we're checking to see can he go left. Now, of course, if he's left on a pole, I said that backward. Actually, right would have him walk off the pole, but it might depend on which way the pole's facing too, now that I think about it. So if you're climbing up a pole that's facing toward you this way, then essentially you're not going you want to check to see how far he can go left. But if you're climbing a pole that's sitting on the right, you want to check to see what's going on the right and see if there's a wall in that direction. So essentially it does it for both, of course. And if there's no block going on here, then we're going to go to the left so he can move left at that point. In other words, the passage is free. And here's our vertical check. I'll jump back here a minute to show you so we don't lose you. So remember, if we're not checking left or right, the first thing we're going to do is say it's equal to 0. So there's no activity going on with the horizontal position. In other words, he's not moving to the left or right. So we're going to go to and check the vertical position, which essentially is now going to allow the sprite to move up and down the ladder, of course, which is right here. So essentially, what you have to do, and I was explaining this a little bit earlier, and I explained this in many other videos, is you got those deltas, right? Those deltas are keeping track of those individual positions. They go from 0, 1, 2, 3, 4, until it leaves the sprite. So if you think of a tile, it's actually made of pixels going from 0 to 4 horizontally, and then they go down vertically, of course. So we're checking them horizontally to see if the sprite is colliding with anything as he's moving up and down in that area. So you always want to check those deltas. And essentially, once you pass through the delta, we're going to be able to check the joystick. Otherwise, if it's less, it's going to actually shift the pixel over to kind of keep checking those deltas. Because essentially, again, that's just how the delta subroutine does, which is checking it further. I believe it's like in the sprite routines ASM file or somewhere where it actually does. No, it's in the collision when it checks the collisions, collisions.asm. Okay, so essentially, if the deltas are done, or if the delta is still being checked here, excuse me, because here it's saying if it's equal to 0, if it's still being checked here, it's going to allow him to move to the left until we've actually moved all the way through that. And again, I'm probably kind of repeating myself from earlier deltas, so if you want to check those out, they'll give you a little bit more explanation, because I don't want to throw too much at you because it can get really overloaded. Okay, so anyways, we know the sprite can move right because the position is less than 4. So essentially, we're still inside of that tile. So he can still move through it until he's reached the end of that tile. And this is a tile like the ladder. So the ladder is open for collision, non-collision detection because you can move around in the deltas on the ladder. But as soon as you're moving across the deltas, you're going to counter another tile, which starts again, resets the delta back to 0 and starts checking that next tile, which of course could be a wall. And at that point, it would stop you. Okay, so I went too fast here. Okay, so the next thing, once we've gone through the deltas, is we're going to check the joystick vertical position for to see what the joystick is doing. Again, if there's no activity, we're just going to end and exit this subroutine. Otherwise, we're going to be able to check, again, that negative value, which is actually for up, and positive value, which is for down. And here it's essentially when we're moving up, again, as we're moving up a pole, something could be in our way, right? There could be a floor above us. There could be anything above us. So we want to make sure we always check that so we don't end up passing through that tile to create that collision detection properly. And of course, if there's no collision, then we'll go down here. We're free to move the sprite's head and body position up and down the tile, which would be the ladder. Now, the next thing we're going to do is the same thing with our down. We're just going to be moving the down position. Now, on this one, I probably should add something later because if I do put something on the ladder later, he's going to be able to walk through it. But for now, I just left it as is because I don't have anything in the project that's actually checking anything. And when he gets down to the bottom, it's already checking the floor anyway in another subroutine. So it works the way it does. So I'll leave it the way it is for now. Okay, and here's our incline. So again, we're checking, and actually I think I am checking. Oh no, this is it incline. Let's see, that's where he's, go back here. Actually, you know what? This one is not implemented. Okay, I took this out initially because this was probably that detection I had initially whenever the sprite was climbing down the ladder, and I just removed it because I didn't need it. But this is essentially what that would be doing, is checking the down position as he moves down the screen, of course. And then here's our idle if we've exited the subroutine, and this is just keeps our turns our animation off because once we've left the ladder, we don't need any more animation. But as he's moving up and down, you got the animation going on. So the next part we're going to be doing is testing what's called the floating. Now, as I mentioned earlier at the very beginning and even a little bit into the video here, is whenever the sprite lands in water, we want to be able to check that as well because the water is going to have its own different properties, just like a pole has its own properties, a floor has its own properties, and its own different collision styles that you would use. In this case, when you land in water, you don't want to treat it like a ladder where you can just move up and down like you were on a ladder, right? You wouldn't need to really check if you're falling off of water because you're already in the water, but you would check if you're leaving the water. Okay, so here I've got the substate going for this one. I didn't actually include any animation because I'm saving that for a later project because I know I kind of added a little bit extra in this project, which really wasn't going to include the water animation, but I figured you guys waited long enough and I worked on it really hard and I just wanted to show you what I was working on anyway. So we'll continue to step up the game, but for now we're gonna get to see it. Okay, so initially here again we're checking is that joystick movement doing anything. Otherwise, you'll see it here creates the fixed pause for scroll resetting. Initially, this was a pause that was set to scroll. I think it was implemented by Siggy way back then, who was the initial developer of this earlier project. In some of the scrolling routines that he created, but I noticed they weren't really used heavily and he probably took them out. So essentially that's what was going on. But anyways, it's the same thing. If it's the joystick is not is stopped movement, then it's going to go to input. So in other words, the screen is not scrolling and we're just checking the sprite in the water now. Okay, so as always, again, we're going to always check the horizontal position because otherwise when you get to the water, again, we got a different tile going on here, different collision properties, right? If you don't, because we're in a different subroutine, keep in mind we're not in idle and we're not in the pole routine, we're in the floating routine or player state floating. So if we don't check anything, he won't be able to move left or right. So you have to check it. So this is why I put left water move and right water move for those negative and positive properties here. Well, essentially I'm saying here, if it's not equal to 0, then it's going to be any other value, which will allow them to go right at that point. Okay, and then here we're essentially saying if, now here's a trick we did. Since we didn't really need to do anything else in the code down here or exit the subroutine, we can immediately go in and check the next vertical position, which is why I have them kind of layered on top of each other here. So in this one, now we're going to be checking to see is the joystick equal to 0, right? Is the vertical position is not moving up and it's not moving down, it's not moving left or right, then we're going to be doing something totally different, which is the actual floating subroutine I built into the project, which I could have renamed it here, but I just called it check water collision for now. And here, this is the joystick moving up, otherwise it's moving down. And essentially here, we got the right water movement going on. So this is just allowing the player to move right in the water. Now you'll notice I took off the second one here, where originally we had the second LDX number 1, JSR move player right. This initially is really cool. What it actually does is it slows the sprite down. So if you're in water, you want to simulate that that effect of like he's moving slower through water, because if you get in water, you're going to move slower, right? And essentially the left is doing the same thing, except moving left, moving slowly. Okay, now here's the right routine and here's the left routine if we're moving left and right. That's just calling those different subroutines. Okay, so now here's our up position, and I put in water, can only move up when in the water. So essentially, the player can move up and down. I mentioned initially that the project would only be able to move when he's touching the ladders, right? But when you're in the water, however, you can move around. You don't really need, it's kind of like flying in a way. I kind of think of it that way because you can move anywhere in water, like you're floating high above the water there, because there's less gravity properties, of course. So you kind of float instead. So anyways, initially here, kind of like being on Mars or whatever you want to think about it. So because we have the up subroutine, we're going to be checking to see can he move up in the water. And we always want to again check the collision properties as he's moving up inside the water. The only way you can exit the water at this point in the project is if there's a pole nearby. So I have a kind of if you've seen at the very beginning of this video PowerPoint, you saw a little ladder hanging down and he was initially on a ladder. So if he's in the water and he sees a ladder nearby and you move up, he can go up and down the poles, which you'll see later once I add the actual video project for this, where you see the actual live example and all that. And maybe even I'll throw it in here and stuff like that. But initially, that's what's going on here. So here again, we're checking and we're just doing a straight collision detect to say, okay, we found a pole, then we're going to be able to go up, right? Because we're checking the up movement. Otherwise, we're exiting the subroutine because we're not doing anything else with it. We're ending. Okay, so the next one here says, in water, can only move down when in the water. And again, it's kind of similar. Since he's not just walking around on the floor looking for a pole, he's in the water, he can move up, and then he can move down as well. And initially here, I think I might need to rename that. I'm not sure why I would have called that check water up. Let me see something here. Okay, that is the up movement. Okay, so that's the up movement. I think maybe this one is not in routine. I've done a lot of changing in this project, so some of this stuff has been removed, so excuse me on that. But anyways, we're going to be checking the water up position and check to see if there's a pole there. If there's not a pole, then we must be, we're going to be going up. Now, essentially going up is going to be, if you're not moving the sprite up the screen, he's going to be floating anyway, which is why I'm always going back to check for it, going up. And initially here, if there's no pole, oh, actually this one's saying, excuse me, let me back up here. So this one is saying, yes, if he's found a pole, he can actually exit the water. So he's going to be able to go up the pole, which is why I called it going up. And initially here, we're saying otherwise we're in the water, so we're going to be going up, which is going to be the floating subroutine. And here we see that going up is doing exactly that. It moves the player up the screen here. And initially I took this one out, but it's been left in for this project example because I forgot to remove it. But anyways, it would allow him to more slowly float up to the top of the water. Otherwise, in water, can only move down when in water, of course. Again, we're checking to see is there water here, and if there is, we're going to be going down. So now he's pushing down, so we're kind of moving against that downward thrust in the water. So he's going to move slowly down. And here's the going down, just to move the player down. And here we're seeing check the water collision. So in water, sprite rises to surface. So yeah, here we go. So to check water collision is actually going to allow the sprite to rise to the surface, because initially I had him sinking and I thought, well, even though you might sink in water, but more or less likely you're going to float on the water. So I initially just made him float back up instead. So we're checking to see if the water is there, and if it's not, it's going to end. Otherwise, the next sequence down here will check he's in the water. And initially here, so now we know we're not checking the joystick, we're not moving it or anything, we're just moving the player up the screen. And here I did take out the second one to initiate that slower movement up in the water there. And essentially, that's it for the project. I just want to personally always thank you guys for watching this channel and subscribing to it as always, and just meeting me on Facebook. I appreciate it so much. And thanks for your patience as I worked on trying to get this video out. I know the last video had two kind of appended together, but I didn't actually include a video. So this one, I definitely want to get a video out to really show you all the great changes, and also that I've actually expanded the levels more, and you can actually go further down the screen and even further over on the screen because I've learned a lot more about this project to make it more interesting. Okay, guys, I hope you enjoyed this video of the Commodore 64 game project, video 7, where we actually covered how to collision detection against poles, climbing up and down, and scrolling when you get to the top, and also the water collision with the sprite bobbing up and down whenever he reaches that. And I hope you guys enjoyed this as much as I enjoyed creating it for you as always, guys. And feel free to visit my Facebook page and, continue to like and subscribe, to this channel. I appreciate it and help me grow. And always leave your questions below you have, and any projects or questions you have, more implementation of your projects, you can actually leave on Facebook so I can be in direct contact with you. Thanks for watching, guys. Have a great night.